Hello, my name is Robin Mitchell, and today Electropages is here in Embedded World, Nuremberg, and I'm joined by Jerzy from Kingston Semiconductors.
Hello, it's an absolute pleasure to have you here on board with Kingston Technology. I'm delighted to have this time to answer your questions and tell you about Kingston.
Fantastic. So, as I understand, we've got a new product range coming out today. Is it targeted at embedded devices?
Yes, it's not new in the sense of we released it. It's been with us for maybe 15 years already, but it's new in terms of customer perception. Many of our customers think of Kingston as a traditional supplier of USBs, SSDs, cards, whereas embedded flash and DRAM is kind of relatively less known, but it's been with us for the last 15 years.
And so Kingston wants to kind of bring that out to the market a bit more to make engineers aware that they can also use Kingston technology in their embedded devices.
Totally. And the way we work is we supply our products to the guys who manufacture reference boards. Let's say Texas Instruments, BeagleBone Black, IMX from NXP 6, 7, 8, and that allows engineers to see us on BOM of design, and that gives them extra confidence that Kingston is the right company to work with.
And so these reference designs also help engineers integrate the technology into their devices as well.
Totally. Well, if you're a manufacturer of embedded products, you have two options. Either you do everything from scratch, so you buy components and you design it, or you kind of buy a solution. So you work with board manufacturers like Congatec, like Seco, like Avnet Embedded, and it will be Kingston interest to get on the reference board for these guys, so that customers can buy a solution including Kingston.
So these embedded memory devices, are they SD cards, micro SD cards, or are they dedicated ICs?
They not in the same as embedded cards. They you could look at them as a embedded flash card, but they different in the sense of support. You expect from products like that to be able to deliver some kind of a longevity, control bombs, PCNs, stable firmware, basically no change for a few years.
So what's the package? What kind of package are we talking about?
It's 153 BGAs.
Oh, right. It's got quite a lot of pins in it.
11.5 by 13. And the capacities, you would be surprised. You could actually have 256 gigabyte or more inside
in an embedded device?
Totally.
256 gigabytes?
Yes.
I can't imagine what you do with 256 gigabytes.
And it also has a controller on board that takes care of wear leveling, of garbage collection, of bed block management. All that is included.
And that's a good question about block wearing, because I believe behind me, or maybe in front of me, we've got a presentation showing block wear.
Yes, totally. And customer always ask, or many times ask, what is your wear leveling algorithm? And the answer is, well, we use both static and dynamic. But nobody's seen it in practical application. Nobody really knows how it works. So what my colleagues in the United States, led by John Turpin, the engineering manager, came up with was an animation how the true wear leveling actually works. So you would see blocks, virtual blocks, and erase counts. On the x-axis would be virtual blocks, and the y-axis would have erase counts. And you see, I guess the gist of that video is, if there is a static data, you don't want to have some blocks running out of life sooner than others.
Of course.
So at Kingston, the target is maybe 50 to 80 erase counts between the youngest and oldest blocks. So, and then the reason you don't want some blocks to run out of life sooner is because you have a limited number of blocks.
Yeah.
And if you run out of spare blocks, then the game is pretty much over. You don't want to have a situation. So our task, target, and objective is to make sure that all blocks on this embedded flash wear out at the same, more or less at the same time.
So does that mean that your device automatically handles block allocation to prevent wearing down.
Totally.
And so it's not a software solution at all.
No, it comes with actually it's an ARM-based processor on board. It's a full-blown processor on board of this tiny design.
So it's dynamically allocating blocks to ensure that you don't essentially wear down blocks, and the engineer is completely oblivious to it. They want to know, obviously, if this will be taken care of. Otherwise, they need to write the code. That's brilliant, because obviously, because a lot of there are a lot of products on the market that have this kind of issue. I think one of them was Tesla, where they had to recall a number of vehicles because the onboard NAND in their device was wearing out too fast because they were doing a lot of logs, but because they were using NAND and they were writing a lot, they didn't have the leveling code to make sure that the blocks weren't constantly using the same slots.
Oh, really? I wasn't aware of it. They struggle with it.
As well as they were filling up too fast as well. But
right, yes.
But that's really interesting.
Basically, exactly the point of wear leveling. But it's not new for Kingston. It's basically customers may not know that this tiny embedded flash has a true controller on board that takes care of things like wear leveling.
To be fair, I always thought wear leveling was actually done from a software point of view. I always thought it was a software problem, but I wasn't aware that Kingston already has technology to basically take that out of the equation for engineers, so engineers can spend more time focusing on the design and less time worrying about the device wearing out.
Absolutely. It used to be a software because traditionally in the old days you would have an SLC NAND or any kind of NAND, and you would have to write the software for each generation of NAND. So as you know, Robin, the generation of NAND changes every 2-3 years.
Of course, very, very quickly as well.
Every semiconductor will promote a new generation. They'll offer you better prices, and then at some point they will say no more. Yeah. So it's very important that when this change happens, customers are not required to rewrite the code.
Basically,
it's a hassle.
So it's kind of like you need to make sure you've got backwards compatibility so people don't have to keep trying to figure out how everything's working because the technology changes so rapidly.
Yes, totally. And JEDEC standard helps the eMMC or embedded multimedia card complies with the JEDEC standard when obviously by Kingston we offer the latest JEDEC 5.1 devices, but also we provide some kind of help with the backward compatibility.
Yeah. So where does Kingston see itself going towards the future as memory technologies change?
Well, I can pretty much talk about my division, which is the embedded division at Kingston, and it's an excellent question, Robin, because you want to make sure that in 10 years old or in 10 years from now you have the right product. So I think at Kingston we have a general consensus that customers will always look for the low cost to the market, low cost of a device, and the requirement for 4 GB, 8 GB, and 16 will still be there in maybe 10 years. So we want to make sure we have low capacity products as well as predict what is going to be on top of the world when it comes to new technology. So we have products like UFS. We have all kind of hybrids, eMCP, combination of eMMC and low power DRAM on board of one chip, and also work on new technologies like NVMe, for instance.
Fantastic. Now, for the engineers who are watching this podcast, what should those engineers do if they want to get in contact with Kingston to integrate these new technologies?
It's very easy. For engineers, you want to be able to buy samples.
Yep.
And we work with companies like Mouser and DigiKey in terms of quick samples delivery, or they can get directly in contact with Kingston so we can ship them a free sample or several samples within a couple of days.
Fantastic.
So I think that's the important part for the engineers, and also things like reliability, stability, longevity. That's what Kingston offers to these guys.
Well, thank you ever so much for taking the time to see us today.
It's been an absolute pleasure to talk with you.
Thank you.
Thank you.